Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Hi guys, Madam Mariam here. We meet again on the fifth subtopic of this chapter, which is thin lens. So today I'm going to introduce you to lenses, where we have two types of lenses, which is convex and concave. So what's the difference between convex and concave lens? Convex lens have an outer surface that is thicker as compared to concave lens. The convex and concave lens also have different functions. For convex lens, the function is to converge light, whereas for concave lens, the function is to diverge light. So I'll show you an example. Let's say light passes through from left to right. We'll look at convex or converging lens first. So light moves in a straight line, and it will be converged to the focal point. The focal point I will explain later on. Okay, so this is the function of a convex or converging lens. But diverging lens has the opposite function, which is to divert the light. So let's see here. Light goes in a straight line. Supposedly, it should be converged, but it is diverged because it is focused at the focal point in front of the lens, as compared to the convex lens, where the focal point is at the back of the lens. So this is important for you to remember. For a convex lens, the focal point is at the back, whereas for concave lens or diverging lens, the focal point is at the front. Now, why do we need to know whether the position of the focal point is at the back or at the front? Later on, we will learn more on image tracing. So your image will be either at the back or at the front of the lens. If your image is at the back of the lens, it is positive, whereas if the image is at the front of the lens, it will be negative. So what's the difference between negative and positive image? A positive image shows a real image, and a negative image shows a virtual image. So I'll explain more on this later on. So these are the types of lenses besides just the converging and diverging lenses. So what I've shown you before was a double convex and a double concave lens. If it is cut in half, it will be called plano convex and plano concave. If you cut it more, cut it again, it will become convex meniscus and concave meniscus. So these are the types of lenses. Now, I've mentioned before, these lights will be focused at the focal point. So a focal point is where the light will be focused at, and the distance from the lens to the focal point is called the focal length. So this is important for you to use in the equation that we are going to learn later on. Like I mentioned before, the focal point for converging lens is at the back, whereas for diverging lens, it is at the front of the lens. This is positive f, and this is negative f. So usually optometrists use the reciprocal of the focal length to find the power of the lenses. And the unit for power is diopter, or you can write it as T. I'll give you an example. Find the lens power over 20 centimeter focal length lens. So focal length is the F. So they want you to find the power, P. So P is equals to 1 over F. Put in all the values. Always change it to SI unit. So your focal length is in centimeter, it will be 0.2 meter. So calculate that, 1 divided by 0.2, and you will get 5 diopter. you will not get the power if you don't convert it to SI unit or to meter. So make sure you change the focal length to meter first before you calculate the power. Okay, let's do the second one. Length of what power is required to magnify reading material by a factor of 2.5 when a book is placed 8 cm behind the lens. Now, this question, I want you to do it later on after we've learned about the lens equation. Can you do that? Good. Right, let's go to locating image by ray tracing. I think you've done this before, but let's refresh. So another way for us to locate image besides equation, we can also do ray tracing. So this ray tracing sometimes comes out in final examination or even in test, but most of the time you can use it to check your answer or to double check your calculation whether it is correct or not. So how do we do ray tracing? Number one, draw a straight line from the height of the object which is parallel to the axis. So it has to be parallel to the axis. Stop at the center of the line. So you must always draw the center line. So once you stop there, continue towards the focal point. Now you can see here there are two focal points. Don't be confused. Focal point can be behind and also front of the lens. The only difference is whether it is virtual or real. So how do you know whether it's virtual or real? Virtual image must be at the front of the lens, negative value, or at the back of the lens, positive value, it is real. So that's the only difference here. So for a convex lens, always draw it towards the back of the lens. So this is the first step. The second step, again, go through the focal length at the front of the lens. So just now we went at the back. Now we go from the front. Stop at the center here. Again, draw a parallel line towards the axis or a straight line. And last but not least, very simple, just draw it through the center of the lens. So where it stops here, the three lines will intersect with each other. So the point of intersection is where your image is. This is the top of the image. So let's say this is your arrow of the image just now, or the head of the image. Where it stops here, this will be the head now. So you can see the image now is inverted. Since it's at the back, it is real and also the same size. So the three characteristics of image that you need to know: whether it is inverted or upright. Second one, whether it is real or virtual. Last but not least, whether it is bigger or magnified or smaller. So how do you determine these three? Look at the position of the image. To see whether it is inverted or upright, look at the head of the image. How to know whether it's real or virtual? Is it at the front or at the back? Again, I'm going to repeat this. Front means the image is virtual. Back means the image is real. Is it bigger or smaller? Look at the size of the image. Is this the same? Yes. You will see a significant difference later on. Let's do this exercise together. Now, the first situation is if the image is located at the point of where any two lines intersect. So let's see, this is the object just now. Remember the first rule? I'm going to do this together with you first. Draw a straight line parallel towards the axis and then go through the back focal length. The focal length at the back of the lens. It would help, or it would be better for you to use a ruler. Since I don't have a ruler here, pardon my not so straight lines. You can do this better. Okay, so the second one, remember, go through the focal length at the front of the lens, stop at the center, and then go parallel towards the axis. Last but not least, just go straight through the center. So you can see the three lines intersected here. The first ray, the first line, the second one, and the third one. So since this is where it intersects, your image will be inverted. Supposedly it should have the same size, but since my drawing is not accurate, so it looks a bit smaller. Let's try another one. Now, this time I want you to try and do it yourself. If the object is outside of 2f, what does it mean by 2f? 2f just simply means that the focal length is double the size of the initial focal length. For example, if my focal length here is 5 cm, then 2f means the position is at another added 5 cm, so the total will be 10 cm. That is just the position of the focal length, just to show that the object's position. So don't be confused by that. Always draw your ray through the f, not to f. To f is just to show the position of the object and the image. Okay, so if the object is outside of 2f, so here's the object. Can you try and do it yourself first? Let's try the first ray. Okay, go on. Draw it yourself first. You're done? Okay, so the first ray will be straight, stops at the line, and then goes through the focal length. Did you get it right? Very good. Okay, let's draw the second one. Ready? Go. Okay, good. Let's check then. So the second one should go through the focal length again, but the one at the front stops at the line and then goes straight, parallel towards the axis. Are you okay there? Okay, try and do the last line, which is the easiest one. I'm sure you would have no problem with this. Yes, the third line will go through the center. Okay, since my lines are not straight, it will be kind of crooked here. So, but yours should be accurate. Make sure you have your notes ready, so you can draw it on the notes yourself. Okay, so let's draw our image then. Since the point of intersection is here, this will be the head of the arrow. So what will be the characteristic of image then? Okay, without looking here, let's try and do it ourselves. Three characteristics. The first one, is it inverted or upright? Yes, it's inverted. The second one, is it smaller or bigger? Much smaller. Last but not least, is it real or virtual? Since it's at the back of the lens, it means that the image is real. So let's check your answer. The image is inverted, correct. It's real, correct. And it's diminished or smaller, correct.